Hello. Back in June of last year, while I had been going out to the Nepean Sailing Club to take pictures of the boats, I had a theodolite app on my phone and I was taking some readings of the Gatineau Hills, thinking that that might come in handy later on. One of the things about the app is the readings for the degrees are only in tenths of a degree, and you need much better resolution than that if you want to calculate the angle to the distant hills. So at this point here, I'm trying to find out if it's level. I'm realizing it's not, so then I go to calibrate it. And at first I tried to calibrate it at 1.0 times, and then I couldn't see the shoreline very well. So then I changed it to 4 times zoom, and then I tried it again. You can see I had rested it on the camera, but even then, despite my best efforts, I couldn't get the thing to stop shaking. But I got it reasonably close enough for my purposes. I kind of saw that it was 0 when it was still lined up at the shoreline, that I went ahead and started to take some readings. I couldn't click on the take a snapshot picture because the camera would twist in my hand and I would end up taking pictures of the sky or take pictures of the water. So I decided to take a video like this with the idea that I could take some stills. When I was going through this, I was trying to find an alternate way of getting the various readings. So you can see that that's not overly useful. So I chose 2 stills. This one was as I was panning up, in this case, frame in question 1624. So here you can see as I was panning up, it was getting close to 1.3, 1.4. So I had chosen the frame before this one said 1.3. This one said 1.4. So this was about the transition between 1.3 and 1.4. And then I chose another one at the very end when I was turning the recording off. I wanted the distance between the shoreline and the water, where the phone was still relatively level, to get a negative reading. You can see where I put the marker over here. So now I have 1.4 degrees. To minus 0.5, which is 168 pixels. So I had put 167 when I was getting this together. 1.9 degrees, which is 1.4 minus 5. And then that gives me degrees per pixel. At this point, if I wanted to find out what the angle was from the shoreline, let's say, to this green line, I've got 35 pixels. So in here, I put in 35 pixels and I get 0.3982 degrees. So the next part was to see if it was reasonably accurate or not. And unfortunately, I was kind of eyeballing where I was pointing, which you can see is nowhere near exact. To make matters worse, I didn't calibrate the magnetic compass on the phone, so I could not get a true representation of the azimuth. But based on this view here, the Gatineau Hills run from about here. Well, they kind of run over here too, but the top of the main prominent hills pretty much run from here to about there. And if we look on a map, I'm standing right here and I'm looking up here in this direction over here. So the Gatineau Hills pretty much run off like this here. So you can see I was standing right over here, looking off in this direction over here. So I was really kind of looking in this direction over here. And so it was more or less lining up with Chelsea. Now keep in mind that this is not an exact alignment. And I've done this a couple of times now, and I'm realizing that there's a few discrepancies, mainly because just a little bit in one direction or the other will give a completely different reading. But overall, I chose this one because it illustrates the first ridge line, which is here, the second ridge line, which is here, and the third ridge line, which is up here. And you can see in the picture, the first is the green, the second is kind of like the brown, and then the third is the gray. So as an aside, in a previous video, my calculations support Miles Davis observations and assertions. I had created a spreadsheet, which is this one. So I copied it, then I modified the values slightly to match my case. The observer height I had put at 57 meters. The water line is 55. And I was about 2 meters above the water line at that point. So that's why I put 57 here. And the first one, which is up here, about 358 at 18 kilometers. Second one is going to be somewhere around here, which is going to be 206 at 13.6 kilometers. And then the third one is either going to be this one or it's going to be this one. But I chose this one because it's slightly higher than this one, 137 at 10 kilometers. And I'm not going to explain the math. I explained already in the other one. But at the end, I had calculated the degrees from eye level if it's a globe earth and degrees from eye level if it's a flat earth. And just for fun, I also compared that with Walter Bisland's calculator. Here is the last one, 18 kilometers and 358 meters with an observer height of 57 meters. And for the globe, the top angle is 0.8771. And for the flat earth, it's 0.958. So let's start with the first one. And let's measure, let's say from here to about there. So that's 37 pixels. And I've got 0.4209 degrees, which is somewhere between globe earth and flat earth. Let's try the next one, maybe over here. 53 pixels, 0.6029, still somewhere between globe and flat. And finally, the last one. Now you can see in this one, it really depends where I was really pointing. The discrepancy in these values could be because I'm looking in one location on Google Earth and I'm pointing in a different location through the theodolite app. But if I pick this one, I've got 72 pixels, which is 0.81916, which is lower than the globe Earth and much, much lower than the flat Earth. The other thing to consider is that this was taken in the summer and the trees could have made these appear higher than they really did, which would explain why my readings are higher than the globe and lower than the flat Earth. But overall, my estimates seem to line up with the globe Earth more than they line up with the flat Earth. So now that I know that this is possible, next summer, when I try something like this again, I think I'm going to try a slightly different approach. So that's it for the moment. Thanks for watching, and I will see you again hopefully in another video soon enough. Bye for now.